Now imagine a tiny particle, like a proton, zooming towards your hand at 99.99% of the speed of light. Would you feel anything at all when it hit you? The night of October 15, 1991, a mysterious particle zoomed through space with the power of entire stars packed into tiny atoms. Its energy was 40 million times the energy of the most powerful protons ever produced in our most advanced particle accelerators, like the Large Hadron Collider. Moreover, it was incredibly fast. Its luminous tail even broke the particle speed limit. According to some scientists, any particles going that fast should eventually slow down. But this one didn't follow the rules. It just kept going just a tiny bit slower than the speed of light. The scientist, John Lindsley, was so shocked he exclaimed, "Oh my God," when he first saw this data. So that's how they named this thing, the "Oh my God" particle. Now imagine a normal particle, like a photon, traveling through space alongside this crazy racer. Well, the OMG particle has energy that's 100 quintillion times greater than those of photons. From our point of view on Earth, it would take the photon over 215,000 years to gain even the tiniest lead. If we look at its energy, it would be like a baseball thrown at almost 60 miles per hour, which would hurt if it hit your bare hand. Ow! But surprisingly, if the OMG particle aimed at you, you wouldn't feel a thing. It would simply pass through your hand. It could scatter some other particles around, but overall, the impact would be unnoticeable. And it's all because of how cosmic rays work. You see, when you're in space, there are tons of invisible particles zooming around you at incredibly high speeds. They're like tiny supercharged balls of energy. These speedy particles are called cosmic rays. Now, we normally encounter the aftermath of their atmospheric dance at sea levels. Most of the cosmic rays consist of lone protons, with just a dash of heavier particles. The higher the energy, the rarer the ray. They come from various places in the universe. They come in two flavors: galactic cosmic rays from outside our solar system and solar energetic particles emitted from the sun. We're mostly protected from them thanks to our Earth's magnetic bubble, the Magnetosphere. This protective shield deflects many charged particles, including cosmic rays, away from our planet or directs them toward the polar regions. And guess what they cause there? That's right, the famous, beautiful aurora borealis. The northern lights that we often see in the Arctic and Antarctic regions of the Earth are caused by travelers from outer space. But it's not like none of them ever reach our planet. In fact, we're surrounded by cosmic rays everywhere. Thousands of these rays are dancing around us every second. And they don't just surround us, they're hitting us and passing through our bodies. However, despite that, we don't feel a thing. That's because, even though they're very energetic, they're still super small and low mass. In fact, they're so tiny that they often pass through the spaces between atoms and even inside the atoms themselves with minimal interaction. Because of all of this, we had no idea that they existed until the 1910s. A long time ago, scientists found out that the air high up in the sky has some special stuff called ionization. Ionization is when atoms or molecules gain or lose electric charges, turning into ions. In simpler terms, it's like giving a neutral thing, an atom or a molecule, a positive or negative charge. These charged particles then can do some interesting things. For example, they play a big role in electricity, allowing things like lights and electronic devices to work. In any case, scientists wanted to know where ionization comes from. They first thought it came from radioactive things in the ground. But then, in the early 1900s, a couple of scientists went up in balloons and found out that this ionization increases the higher you go. Turns out, something from space, not the sun, was making this ionization. Scientists learned a lot about them over the years, like where they come from and what they're made of. And that's how the cosmic rays were discovered. The mysterious OMG particle we've talked about was one of those cosmic rays. This particle was detected by the Fly's Eye camera in Utah in 1991, and to this day, it holds the record as the highest energy cosmic ray ever spotted. Obviously, it sparked scientists' curiosity. They wanted to find out where this supercharged particle came from and how it got its incredible speed. So they decided to investigate it. And the more they studied it, the more weird things they discovered. For example, they found out that time itself stretches out for this particle because of how insanely fast it is. Special relativity, an idea created by Albert Einstein, says that as you speed up, strange things happen. And when you get close to that light speed zone, time starts playing tricks. For example, if the OMG particle started its journey from a spot that's 1.5 billion light-years away, for the particle, it would feel like just around 2 days have passed by the time it reaches us on Earth. Since scientists discovered this amazing oh my god particle, they've found hundreds of similar super-energetic events happening in space. But it's extremely hard to find out why they move the way they do. All the theories have their own problems and bumps. One suspect is supernovas, massive star booms with magnetic fields and energy. However, it looks like even their great energy isn't quite enough to create an OMG particle. Another top suspect was Centaurus A, a nearby active galaxy. But the evidence for this one is tricky, because the Milky Way's magnetic field alters the paths of cosmic rays. Of course, there are some crazy and exotic possibilities, like topological defects from the Big Bang or mysterious interactions within dark matter. Scientists are exploring wild ideas as well. Who knows? Maybe it's really some crazy twist of physics. High-energy astrophysics is also super helpful for studying and understanding cosmic rays. This is a field of study that explores highly energetic stuff in space, like extreme cosmic events. Scientists are interested in understanding how cosmic rays are connected to these wild events happening out there. Unfortunately, even after almost 30 years of detective work, the true origin of the OMG particles remains a mystery. Luckily, recent studies might give us some hints for the answer. In the large deserts of Utah, there's a thing called the telescope array. It's searching for superfast particles called ultra-high-energy cosmic rays. Picture a massive grid of detectors spread across the desert, keeping an eye on particles all day long. And here's what it discovered recently. There's a specific area in the Ursa Major constellation. At first, scientists didn't think much of it, but then they analyzed the data thoroughly and realized it was important. This exceptional area is a warm spot where these cosmic rays might be coming from, and it has almost 100% chance of being real. It sounds like the universe's hidden energy source, but what is this source and why does it exist? Cosmic rays aren't just intriguing for astronomers, they also have earthly applications. In 2017, researchers used cosmic rays to discover a hidden void in the Great Pyramid of Giza. They used muon tomography, a method that examines cosmic rays penetrating solid objects. And this is how scientists unveiled the secrets of the ancient structure. Scientists also use them to look inside volcanoes. They use the same method as with pyramids. When these rays pass through a volcano, scientists can study how they move to create images of what's inside. This helps researchers figure out where different materials are in the volcano and keep an eye on any signs that it might become active. So, the more we learn about them, the more we learn about the mysteries of our universe. Scientists had to build better detectors to learn more. Thanks to all the new technology, they're learning things very rapidly. So let's see what truth they'll discover in the future. The protective shield of our planet decays and eventually fails. So do our satellites. First, communication satellites in the highest orbits go down. Next, astronauts in low Earth orbit can no longer contact their mission control center. And finally, hazardous, relentless cosmic rays start bombarding everything on Earth, causing havoc and devastation. Are these the terrifying consequences of the planet's magnetic field reversal we're going to face? Right now, as you're watching this video, Earth's north magnetic pole is extremely out of whack. It's so serious that scientists will have to update the global magnetic field model released a mere 4 years ago. Does it all mean that the magnetic pole of our planet will flip soon? Well, be patient, we'll figure it out a bit later. You see, the magnetic pole is moving quite erratically from the Canadian Arctic towards Siberia, and these movements are very unpredictable. But it's normal for the pole to be moving. There are long-term records from London and Paris that prove that the North Magnetic Pole moves randomly around the rotational North Pole over periods of several hundred years. But the most astonishing thing about its movement is that it's speeding up. Around the mid-1990s, the magnetic pole unexpectedly accelerated from a bit over 9 miles to 34 miles a year. And recently, the pole crossed the international date line, moving toward the eastern hemisphere. The European Space Agency launched extremely accurate magnetic field satellites in 2013. Thanks to them, researchers have superb data they can use not only to make magnetic field maps, but also to update them every 6 to 12 months. That's how they were able to notice that the core field was weakening too. It might be a sign that the planet's magnetic field is about to flip. To understand this process better, we need to figure out how the core field works. Let's say we've got a bar magnet that runs through the center of our planet and has a north and a south pole. This magnet is incredibly strong, representing about 75% of the intensity of our planet's magnetic field at the surface. Our bar magnet is not only moving, but is also getting weaker, by about 7% every century. Admittedly, this bar isn't the perfect representation of the core field. It's more like electric currents generating Earth's magnetic field. Still, this model makes it easier to see what's happening to our planet now. The magnetic field of our planet plays an important role in protecting us from dangerous radiation and geomagnetic activity, which is the product of the interaction between the solar wind and Earth's magnetosphere. Earth's magnetic field also moves. Scientists have been studying and tracking the movement of the magnetic poles for hundreds of years. The historical motions of these poles indicates changes in the global geometry of the magnetic field of our planet, and they may point to the beginning of the field reversal too. That's what the flip between the north and south magnetic poles is sometimes called. You see, if the north magnetic pole moves a bit, it isn't a big deal. But a complete reversal might have a serious impact on the climate of our planet, as well as modern technology. Luckily, such flips don't happen overnight. The entire process stretches over thousands of years. Plus, even though the magnetic pole weakens during a pole reversal, it doesn't disappear completely. So those scary events from the beginning of the video aren't likely to happen to us. The magnetosphere will continue protecting the planet from cosmic rays and charged solar particles, even though there might be some amount of particulate radiation that will make it to Earth's surface. Magnetic fields are generated by moving electric charges. If some material allows these charges to easily move in it, it's called a conductor. Metal is a great conductor, and we often use it to transfer electric currents from one place to another. In this case, the electric current is negative charges called electrons moving through the metal. The current is what generates a magnetic field. Earth has a liquid iron core. In other words, there are layers and layers of conducting material inside our planet. Currents of charges are constantly moving through the core, and the liquid metal is also moving and circulating there, generating the magnetic field. This magnetic field, in turn, produces something resembling a bubble around the planet. It's called the magnetosphere, and it's located above the uppermost part of the atmosphere. This layer shields and deflects high-energy cosmic radiation, which otherwise would be extremely dangerous to people and other forms of life on Earth. The magnetosphere also interacts with the ionosphere, the layer of our planet's atmosphere containing loads of ions and free electrons and capable of reflecting radio waves. The interaction between these two layers and the magnetized solar winds is what scientists call space weather. The solar wind is normally mild, and there's no space weather whatsoever. But sometimes, the sun starts shedding gargantuan magnetized clouds of gas that can accelerate to incredible speeds. They're called coronal mass ejections, or CMEs. They're ejected from the sun over the course of several hours. CMEs usually look like giant twisted ropes and can occur spontaneously. Their frequency varies according to the 11-year-long solar cycle. For example, at a solar minimum, you can observe 1 ejection per day, and when the Sun is in its most active phase, there might be 3 CMAs per day. Coronal mass ejections disrupt the calm flow of the solar wind and cause serious disturbances that can damage stuff both in space near Earth, like satellites, and on the planet's surface. If coronal mass ejections make it to Earth, their interaction with the magnetosphere generates geomagnetic storms. Those can trigger auroras, happening when a stream of energized particles hits the atmosphere and lights up. And then there are also solar flares. They develop more rapidly and with much more energy than coronal mass ejections. Solar flares often occur soon after coronal mass ejections. The most powerful volcanic eruptions pale in comparison to solar flares that release 10 million times more energy. Within a few minutes, one solar flare can give out billions of tons of charged particles. Solar flares are also insanely hot, with temperatures reaching several million degrees Fahrenheit. Astronomers believe that such bursts of solar radiation happen when the Sun's magnetic field gets twisted in some regions. At one moment, all the pent-up energy is released. The star sends out light and particles, mostly electrons and protons. Most solar flares last for minutes, but some continue for hours. A powerful solar storm can potentially cause a devastating global blackout on Earth. If not for the Earth's magnetosphere, the effects of the Sun's activity would be much more devastating. Luckily, the magnetosphere deflects most of the solar material hurtling towards our planet from our star at a speed of over 1 million miles per hour. But even so, during space weather events, there's a lot of hazardous radiation near Earth. It can potentially harm astronauts and spacecraft. Plus, space weather can damage large conducting systems, for example, pipelines and power grids, by overloading currents running inside them. Scientists regularly map and track the overall orientation and shape of our planet's magnetic field. To do it, they use local measurements of the field's orientation and magnitude. That's why they've been able to conclude that the location of the North Magnetic Pole has moved by almost 600 miles since the first measurements were taken in 1831. The magnetic field of our planet reverses on a timescale varying between 100,000 to 1 million years. One can tell how often it happens by looking at volcanic rocks at the bottom of the ocean. They capture the orientation and strength of Earth's magnetic field at the time of their creation. So, dating those rocks gives us a good picture of how our planet's magnetic field has evolved over time. From a geological point of view, field reversals happen quite fast, but they are extremely slow from a human perspective. A complete reversal normally takes a couple of thousand years, but during this time, the orientation of the magnetosphere may shift, exposing more of Earth to cosmic radiation. Such events tend to change the concentration of ozone in the atmosphere. In any case, scientists can't say for sure when the next field reversal will happen, but they keep mapping and tracking the movement of our planet's magnetic north. By the way, the Earth isn't the only planet with a magnetic field. Gas giants, like Jupiter, also have a conducting metallic hydrogen layer that generates their magnetic fields. Jupiter's internal magnetic field prevents the solar wind from interacting directly with the planet's atmosphere.
A solar storm is crashing into Earth like a cosmic tsunami. First, the atmosphere ignites, sparking massive auroras. High-energy radiation slams into the surface, frying power grids, turning lights off across continents, and knocking out satellites. Planes lose navigation. Radios go silent. GPS systems crash. Radiation levels spike dangerously. Communication collapses, emergency services scramble in the darkness, and chaos spreads as people struggle to cope. Solar particles start to strip away the very air we breathe, slowly peeling off our atmosphere. Soon, Earth will become a harsh and hostile place. That's what solar activity can do to our planet and its inhabitants if we didn't have a protective shield called the magnetosphere. But even with this barrier, we're still in for serious problems. A mysterious 100-year solar cycle may have just restarted, and it could mean decades of dangerous space weather. New research suggests that the unexpected intensity of the ongoing solar maximum may be partly tied to a lesser-known 100-year solar cycle. If the Sun is indeed entering its villain arc, solar activity could spike even further in the coming decades. It means more solar flares, more chances of them messing with satellites, and way more of those crazy northern lights people keep posting on Instagram. Sure, not everyone's buying it. Some space nerds want more proof before jumping on this solar hype train. Let's break it all down into detail first. The Sun goes through a kind of mood swing every 11 years. This is called the solar cycle. It starts off at a solar minimum, which is pretty chill, then slowly gets rowdy. We're talking sunspots, solar flares, and other fiery drama. Once we reach solar maximum, the situation starts to calm down again. The Sun gets sunspots, dark patches on its surface, like the freckles we humans have, when its magnetic field starts flipping out. Literally, the Sun's magnetic field completely flips during peak solar drama. Scientists track how many of these spots show up to measure how spicy the Sun is getting. But wait, plot twist, there are other cycles too, like the Hale cycle, which occurs around every 22 years. This cycle controls how magnetic fields move across the Sun. Plus, way back in history, there were moments when the Sun basically went on Do Not Disturb mode. During the Maunder minimum, our star was basically in sleep mode for 70 years. In other words, the Sun might be entering a new extra phase, and things could get dramatic. On the bright side, that means more auroras. At the same time, it could also cause issues for satellites, GPS, and other stuff we rely on. Ugh, let's just hope it doesn't mess with YouTube. This extra phase is called the Centennial Gleisberg cycle. It's basically the Sun's once every 100 years I do something weird moment. Scientists think it messes with how intense sunspot cycles get. No one has fully worked out how this cycle works yet, but some low-key sloshing of magnetic fields inside the Sun might be causing it. Yep, I did say sloshing, like a giant cosmic smoothie. A recent study from March 2025 claims that the CGC might have just hit restart. That could explain why this current solar maximum, the Sun's drama phase that started in early 2024, is being so weird and unpredictable. How did researchers figure this out? They looked at something called proton flux. Basically, it's how many positively charged particles are flying around in Earth's radiation belt. There are 2 of these belts, shaped like donuts that wrap around Earth, full of particles from the Sun. The thing is, when the Sun is active, our upper atmosphere swells, which makes the inner radiation belt lose some of those protons. And when the Sun is chill, proton numbers go up again. So those protons have been increasing for like 20 years, but just started to drop in the past year. Which basically screams, CGC has just hit minimum. Time for the Sun to crank it back up. The data came from NOAA satellites that flew through the South Atlantic Anomaly, which is like the Bermuda Triangle of space. It's this bizarre zone over South America where Earth's magnetic field is weaker and space radiation gets closer to Earth. This area is perfect for observing proton activity without sending a satellite into the actual danger zone. So, right now, we're probably nearing the end of the Sun's current chaos phase, aka the peak of solar cycle 25. Back in May 2024, it hit us with one of the craziest geomagnetic storms in 500 years or so. And yes, that means super bright auroras lighting up skies all over the world, even in places that usually only get clouds and vibes. But the scariest thing? This wasn't supposed to happen. During the last cycle, the Sun was oddly calm. So NASA and NOAA looked at that and thought that the next solar cycle would probably be the same, no biggie. Well, they were wrong, and they even admitted it. Now, scientists think that SC24's quiet phase was because of the Centennial Gleisberg cycle being at its low point. That probably made it the quietest sunspot cycle in 100 years. So now that SC25 is lit again, pretty literally, it might just mean the sun is back to doing what it normally does, being a little chaotic and wild. Recent studies think the CGC minimum is finally over. That would explain why the current solar activity is turning up the heat, and why the last one felt like a cosmic snooze. An even cooler thing is that a 2024 study used AI to analyze sunspot patterns and found that CGC might be messing with our forecasts more than we thought. And if this long-term mood swing of our star is really back on the rise, future solar cycles could be just as wild as the one we're in now, or even wilder. After all, we've just passed the CGC's low-energy mode, and we won't hit the next maximum for another 40 to 50 years, around solar cycle 28. That's a few decades away, but the sun's already throwing tantrums. The scariest part is that future solar activity might be twice as intense as what we're seeing now. You might be wondering right now, why should I care? Well, because when the sun freaks out, it messes with our stuff, especially in space. Satellites get dragged out of orbit because Earth's upper atmosphere literally puffs up like a marshmallow in a microwave when solar activity spikes. And this has already happened to a few spacecraft recently. And with tons of private satellite mega constellations like Starlink and its squad, the risk goes way up. There are some, even though those are few, that might not be ready for a full-blown sun rage event. Time to wear SPF 100 for your satellites. Astronauts are also at risk. More solar flares mean more radiation and more danger for humans in orbit. At the same time, more space tourists and missions mean more people potentially in the sun's cosmic splash zone. At the same time, not everyone is buying into the whole CGC is back and ready to party theory. Some experts say it's a cool theory, but we shouldn't get carried away. The thing is, the proton flux, those space particles we've been watching, only started dropping last year. That's not a lot of time. It might just be a short-term dip, like the sun sneezed and now everyone's freaking out. Also, we've only been able to track this stuff properly for 30 to 40 years or so, which is basically nothing in sun time. So there's no solid before and after data to compare CGC cycles and say, yep, this is definitely a pattern. Plus, the CGC itself is kinda mysterious. Like no one can fully agree on what it even is, how it works, or how much it actually messes with sunspot cycles. It's like the Bigfoot of solar science, blurry, weird, and causing drama in group chats. But even skeptics admit that the new study is interesting and well-intentioned, and that it might help us predict future solar cycles better. We just need more time, more data, and better definition of the CGC before we treat it like the ultimate weather app for the sun. This area might just be the most important spot in America right now, as it is worth over $1 trillion. There's something incredibly valuable hidden right here at Thacker Pass, and it is going to shake things up, not just in Nevada, but in the US economy and its global relations. The McDermott Caldera is a massive area, about 28 miles long by 22 miles wide, stretching across northern Nevada and southern Oregon. It's in Humboldt County, a quiet, rural place with just one main city that's going to change a lot in the next 5 to 10 years. That's because they found white gold there. We're talking about lithium. And to explain why this metal is so important, we need a scale. On one side, we place a chunk of lithium, and on the other, an apple. What do you think will happen? If both have the same volume, the scale is going to tip toward the apple. That's because lithium is super light. Its density is about 0.3 ounces per cubic inch, which makes it the lightest solid you can find at room temperature. Lithium is also extremely reactive. That means it combines with other elements very easily, and it can catch fire just as easily. Mix it with water, fire. Expose it to air, yep, fire again. But when you combine its lightness with its high reactivity, you get a material that's perfect for batteries. Like the one powering your smartphone, laptop, or even your electric car. Nevada's been hiding this treasure for about 16 million years. The McDermott caldera used to be a volcanic hotspot, spewing molten rock and creating a huge lake filled with mineral-rich waters. Over time, that lake dried up, leaving behind thick layers of clay loaded with lithium. Right now, Thacker Pass Mine is sitting on one of the biggest untapped lithium reserves in the world, worth about $1.5 trillion. If everything goes as planned, they expect it to produce about 40,000 tons of high-quality lithium a year. And that's enough to make batteries for up to 800,000 electric cars. Like I mentioned earlier, this metal is the backbone of modern batteries. And with the world racing toward green energy, the demand for lithium is skyrocketing. Since 2020, its price has gone up more than 10 times, making it the most expensive battery metal in the world. That means it's way more expensive than magnesium, nickel, cobalt, and other materials used in rechargeable batteries. Right now, we're using about 1.16 million tons of lithium per year, and roughly 85% of it goes into making batteries, mostly for cars. Between 2030 and 2040, experts think we will need to double the money we're putting into production, from $94 billion to $188 billion. At the same time, investment in batteries will jump by over 200%, reaching $686 billion. Finally, by 2050, the demand for lithium is expected to be more than 10 times higher than what we're producing now. Sorry, I know that's a lot of numbers, but I just want to show how important Thacker Pass will be for the whole world. This mine is going to be key to keeping everything running. I mean, literally, since most of the future demand will be for things like cars, electric bikes, scooters, and renewable energy storage. Nevada could also be the epicenter of a global energy revolution, with the US aiming to cut pollution by 50% by 2030. A big part of that is replacing gas-powered vehicles with electric ones. And to make that happen, America is going to need a whole lot more lithium than it's producing right now. Nowadays, most of the metal used in the United States come from countries like Chile and Argentina. So if America wants to be a leader in this market, it really needs to invest more and more in projects like Thacker Pass. But there's another challenge. Finding lithium in a mine is one thing, but refining it is another story. Just like diamonds are carefully cut and shaped to bring out their sparkle and sold in rings and necklaces, something similar needs to be done with lithium. The raw material that comes from the mines has to be refined into a pure form that can actually be used in things like batteries. And China pretty much dominates this part of the market, and they're responsible for about 75% of global lithium-ion battery production. In other words, it doesn't matter if a country finds this powerful metal on its land, it will probably still need China to help refine it. So, the US is eager to strengthen its supply chain. In fact, they're so excited about this possibility that authorities have invested over $2 billion in loans into the Nevada project. Because of that, Thacker Pass could make the US a leader in lithium production worldwide. If their estimates are right, the McDermott caldera could hold nearly half of the world's known lithium reserves. It would almost double the reserves found in Bolivia's salt flats, for example, which used to hold the record for the world's largest deposit. This discovery is about to change Humboldt County for good. Those quiet streets surrounded by nature will never feel the same again. The mine will need about 2,000 workers who will probably move there from other cities. Those workers will need houses, hospitals, schools for their kids, and all the necessary services. Do you see how it's like a ripple effect? For every person hired to work on the project during construction, 6 more people will get hired in the state to support them. Thacker Pass is also going to have a huge impact on the economy, not just in Nevada, but all across the country. People expect the mine to be active for 35 years, and each year it's expected to generate over $2 billion. But here's the thing. In Thacker Pass, they'll be extracting lithium from clay, and this process has never been done on such a huge scale before. So it's kind of a hit or miss. But if it works, it could completely change the industry. Big question. Who's interested in all this? Well, we've got 3 big companies eyeing the lithium market in the US. First, there's ExxonMobil. The oil giant wants to start producing lithium by 2027, and they have plans to become the top supplier for electric vehicles by 2030. Then there's General Motors, the company behind big car brands like Chevrolet and Cadillac. They're so interested in this business that they agreed to pay $625 million for a 38% stake in Thacker Pass. And finally, Tesla. In 2023, they started building a factory in Texas to process lithium. It's all part of their plan to handle more of their supply chain themselves. Now that you know how important lithium is, you might be wondering, what if we run out? Well, that could happen, since it comes from mining and, just like gold, is a finite resource. But that doesn't mean we'd have to give up smartphones or electric cars. If we ever run out of this metal, we'd probably find new ways to produce batteries. In fact, some experts think thermal batteries could be the next big thing. They store extra energy from renewable resources like wind or solar power, which are very cheap. So they represent a new way of storing energy at a small fraction of the cost. Nowadays, they're primarily used for powering the production of steel, cement, and chemicals. Thermal batteries are also being used to heat and cool large buildings. However, more and more projects are focusing on bringing this technology into private spaces, like houses and apartments. Experts are optimistic that initiatives like these could make thermal batteries as well known as electric batteries, and they might soon become a regular part of our daily lives. For every 1.8 degrees Fahrenheit increase in a country's average temperature, the GDP per capita drops by at least 1.1%. To put it simply, with every step you take from the North Pole to the equator, not only do you get hotter, but you also get poorer. Even though life in freezing cold countries can seem miserable, 74.2% of the world's billionaires are concentrated in the global north. And there are at least 4 theories explaining that. The simplest theory is tied to biology. Cold weather is believed to keep germs away, leading to better health and productivity. Sounds good, but I'll challenge that later. Next, there's the sloth theory from ancient Greece, and it's more about climate in general. Greeks believed their ideal weather made them wealthier, while hotter regions were seen as less creative. The third idea is based on economic and anthropological studies. You see, experts noticed some time ago that colder countries have inclusive institutions that offer equal job and life opportunities and protect markets and private property. Naturally, such conditions promote healthy competition and boost wealth. The last idea is tightly connected to the previous one. Long story short, richer countries tend to distribute money better because they're more inclusive. Poorer nations often have extractive institutions where a powerful elite controls wealth. While all of them seem plausible, the truth is, these ideas are borderline insane. Well, you know the theory claiming that cold climates eliminates germs and the population of colder countries doesn't get so sick? I don't want to be the bearer of bad news, but the cold actually makes germs thrive. In the cold, we tend to stay inside with the whole house shut, so we share germs with each other more easily. Not only that, but during winter, the air is drier, creating the perfect environment for the flu virus to flourish. Humans are also more resistant to viruses and bacteria from their own environment because the constant contact with them makes our immune system stronger. If you look back at your history classes, you might remember that most British people struggled with the weather and bacteria found in America, while Native Americans themselves were mostly fine. And what about the sloth theory? Sorry, I don't mean it to sound offensive, but some specialists, they claim that, people in hotter countries tend to be lazier. But the truth is, the sun doesn't make us work less. Yes, the sun can make you a bit slower because you can dehydrate. But you see, the human body is biologically adapted to the climate of the place they're born in. This means that if you live in Canada, for example, you can endure the cold just fine. But Brazilians will probably handle hot days better than you. But if the sloth theory was true, how would you explain that people in Colombia work about 200 hours a year more than those from the United States? In fact, if you live in Cambodia, Myanmar, or Mexico, you're bound to work more than anyone in the world. Besides, hotter countries have a genius way to fight off laziness. It's called siesta. After lunch, it's normal to feel a bit sleepy, and if you have heavier meals like the Spanish and Italians do, you'll get extra slow. This is why after lunch they usually have a siesta, also known as a quick nap, which improves your memory and thinking skills. It may sound like a siesta makes you work less, but people who nap after lunch simply work at different hours of the day. While you make shorter lunch breaks and go home at 6 p.m., in Spain, the lunch break lasts 2 hours and the workday ends at 8 p.m. They work when it's not so hot outside and even get to take a power nap. The past is also crowded with people who lived rich lives despite the scorching sun. The ancient Egypt civilization may have existed thousands of years ago, but they were one of the richest civilizations ever, even though they lived in a place that was super hot and super dry. We also have the Aztecs, who lived in Mexico back when Mexico didn't exist yet. This region is not so famous for its cold weather, I can tell you that. But the Aztec civilization still managed to have a capital that was bigger than London, Paris, and Madrid of the time. On top of that, many of the inventions we have today that make a lot of people rich were created thanks to math and science. Two things born in hot places, like Mesopotamia and India. Now, to make all those economic and anthropological studies sound simpler, let's start with the most obvious part. It's true that hotter countries usually make money out of their natural resources. They don't have such strong industries, and the money is concentrated in the hands of the elite. All of this reduces the GDP, that thing that estimates whether a country is wealthy or not. Remember we said richer countries have inclusive institutions? These institutions are basically laws that make sure people have equal job and life opportunities, including nice houses and a good salary. Poor countries are not very good at this inclusive institution thing, but it's not by choice. This is actually a consequence of the age of exploration. In case you were sleeping during your history classes, let me remind you, the age of exploration is that time between the 15th and 17th centuries, when many kingdoms in Europe were exploring the seas and setting up colonies all over the world. I know it feels like this was a long time ago, but many countries that were colonies back then only became independent during the 20th and 21st century. This is why many poor countries don't have solid industries and markets, because their institutions and laws date back to when they were still colonies, and their years as colonies depleted resources and didn't provide a good infrastructure. Besides, saying that private property reduces the income and inequality gap is kind of absurd. It's true that developing countries like Brazil and South Africa are highly unequal, but in the US, for example, 1% of the richest people in the country make 139 times more money than the poorest part of the population. And there were more than 700,000 homeless people in 2024. Besides, 1% of the world's population is wealthier than the rest of humankind put together. If inclusive institutions were really that powerful in richer countries, then there wouldn't be more than 1 billion people living in acute poverty all over the world. There's no point in saying that private property makes everyone's lives better if people can't even afford to have a house in the first place. And using the GDP to calculate the wealth of a country is not exactly the best way to understand poverty, because the GDP only considers how much money the industry itself makes. It ignores, for example, the question of whether people who work in those industries have good jobs, if they are well paid and have a good life. The GDP also ignores inequality, which means it ignores those inclusive institutions we mentioned before. In the United States, there are about 835 billionaires, but 11% of the American population is still very poor. So, my hot take here is that inclusive institutions are not that inclusive, and that money is not that well distributed in the first place. Different cultures also have different concepts of what it means to be wealthy. In London, for example, being able to afford food, clothes, and shelter does not make you rich. To them, you're simply surviving. If you want to be truly wealthy in London, you might have to hire a housekeeper, buy a horse, and have a personal Pilates instructor. But to the Awa or the Yanomami tribes, money doesn't even exist. They produce only the necessary, and if they have a surplus, they will trade with other tribes. I guess the fact that poor countries are all located closer to the equator line is not just a simple historical coincidence.
So it turns out that so-called rich countries are facing a big problem. People are not having kids. Not enough, at least. On average, women need to have 2 children to keep things balanced, but they're only having 1, or none at all. This issue comes down to the fertility rate, or simply the average number of kids a woman is expected to have in her lifetime. When that number's too low, it means more people are passing away in these countries than being born, and that can destroy the economy. Think of a rich country – the US, Germany, Japan. Great! Pick any wealthy nation you like, and I can promise you one thing – its fertility rate is below 2.1, and that's a problem. Here's why. Meet Mary and John, and over here we've got Jack and Lucy. That's 4 people total. Now, both couples get married. Mary and John have 2 kids, but Jack and Lucy only have 1. Now, what does that mean? Simple math, we're down by 1 person. And if this keeps happening, generation after generation, the population starts to shrink. The situation gets pretty scary when we zoom in on certain countries. Take Spain, Italy, or Poland. These countries have some of the lowest fertility rates in the European Union, with women there having, on average, just 1 kid. And that's a big problem, because it drags down entire economies. Picture a triangle, young people and workers at the bottom and the elderly at the top. In many rich countries, that bottom part is shrinking fast, with fewer babies being born each year. So it's like this triangle is flipping upside down. Fewer young folks and workers, but more and more older people. With fewer workers and more retirees, the economy struggles to stay balanced. It's like the domino effect. Fewer people working means fewer people paying taxes. Meanwhile, the older population at the top keeps growing. And now we have a way bigger group depending on pensions and stuff like Social Security. So we're left asking, who's going to pay for all these retirements? Now, some countries are in hotter water than others, and South Korea is really feeling the heat. They've got more and more people getting older, while fewer and fewer babies are being born. In fact, they've got the lowest fertility rate in the world. In 2023, it hit rock bottom, 0.72 births per woman. Now, personally, I don't know how you can have 3/4 of a kid, but hey, that's statistics for you. Meanwhile, if things keep going like this, Korea's population could shrink by half by 2100. Over the last 20 years, their authorities have invested at the equivalent of $286 billion in this issue, and they've rolled out a bunch of incentives to turn things around. First up, pocket money. If a married couple in Korea decides to have their first kid, the government hands over about $10,000 split into monthly payments to help out. While that might sound impressive, it's only about 3 times the average monthly wage. And in Seoul, one of the most expensive cities in the world, that doesn't go very far. Next, a home. Paying rent in Seoul is insane, but the government doesn't want people to leave the capital because of it. So they're stepping in. Recently, they've promised to give families around $300 a month to help with housing, until the kid turns 2. Then again, $300 seems great, but it only covers about 11% of the rent for a 3-bedroom apartment in the city center. And last but not least, health care. Hospital bills are covered, but the couple must be married, on paper and everything. South Korea came up with all this to fix the problem. Otherwise, their population might get older, poorer, and more dependent on others for care. But when you think about it, all these incentives really come down to one thing: giving out cash. Even so, their demographic problem hasn't gotten any better, so the authorities had to come up with more creative solutions, like offering jobs with flexible hours for parents with kids under 5. And they can borrow things like toys or strollers from the government, totally for free. So, why don't women want to become mothers? There's a bunch of reasons. But one of the most important is work. Women are getting more education and grabbing more opportunities in the job market than ever before. But a lot of jobs have crazy hours, with people working late every single day. So many women get stuck in that cycle, waking up early, going to work, coming home late, and sleeping. Then it all starts over the next day. They don't have time to meet a partner, and even less time to raise someone. In fact, education in general is one of the biggest reasons why birth rates are dropping. Spending so many years in school, then in college, means women are pushing back the age they have their first kid. Once they finish their education, they often want to focus on work and building their careers before starting a family. So they're not becoming moms in their teens or early 20s anymore. And by the time they hit 30, things aren't much better. Sure, they might finally land a stable job, but most employment policies still don't offer enough support for childcare. But it's not only education. Younger generations are getting delayed in, well, everything. I mean, it's way harder for them to tick off all the adulting boxes, like having a well-paying job or buying a nice house. And these things are usually a big part of whether people decide to start a family or not. Another reason people aren't having kids: putting a new human into this world is expensive and time-consuming. The average childcare costs in Australia, for example, have gone up faster than inflation. School tuition, even for public schools, takes a big chunk out of parents' budgets. Think about it: computers, uniforms, field trips, extracurricular activities – all that adds up to the cost of financing someone's education. Over 13 years, parents spend over $80,000 on public education. And if we're talking about private schools, that number jumps up to almost $350,000. And don't worry, these costs are just for one kid. Now imagine having 2 or 3. So what is the solution? Well, there are 2 ways to tackle the problem that don't involve pushing the population to have more kids. Nations can keep their population healthier and employed longer, like what Singapore is doing. They're putting a lot of effort into raising the retirement age, offering midlife training, and encouraging companies to hire older workers, like those over 69. Another way is to encourage people from other countries to come in, especially young ones who are ready to work. That's, for example, the strategy Canada uses. Now, if the goal is really to get women to have more kids, a lot of countries use the baby bonus strategy, basically giving money and benefits to families, just like South Korea does. The problem is that some experts say it is pretty ineffective, as financial incentives don't address the complexity of the issue. For them, what these wealthy countries need to do is offer better career and housing opportunities for young people, like giving incentives for companies to offer more flexible hours or work-from-home options for young parents. They also need to push strategies to lower the cost of housing, especially in big cities. Plus, they need to focus more on the aging population, using technological innovations to support them. That would help not just parents, but families as a whole. So, what do you think? Our planet's biggest and meanest supervolcanoes are waking up. When they erupt, you'll surely notice it, even if you live thousands of miles away from the epicenter. Scientists are worried we might not have enough time to prepare and deal with the consequences of a supereruption. There's some volcanic activity close to the Italian city of Naples. And no, it has nothing to do with the famous Mount Vesuvius, but with another volcano. This one is harder to see as it doesn't have a tall peak like Vesuvius. But don't let this bad guy trick you. It could be way more dangerous than its giant neighbor. It does have a huge crater that's about 8 miles wide. This volcano is called Campi Flegrei, and it's actually one of the largest volcanoes in Europe, sitting under the town of Assuali. So, Campiflagre erupted 39,000 years ago with a bang so massive it spread ash across the whole Mediterranean region. It also caused the temperature to drop by over 16 degrees Fahrenheit across Eastern Europe. It was the biggest volcanic eruption in Europe in 200,000 years. Since then, Campiflagre has had smaller eruptions, and the last one happened in 1538. Now the area is full of small craters, hot springs, and bubbling pools, and they're all proof that this volcano is still very much alive and brewing something. Since the early 2000s, the ground in the giant crater and the town nearby have been slowly rising by about 1 to 1.5 inches every year. There were at least 150 earthquakes that shook this supervolcano lately. In May 2024, there was a 4.4 magnitude in the area, the biggest in the last 40 years. Residents had to leave their homes and camp outside, fearing there would be more earthquakes. No one knows how Campiflagre is going to behave in the following months or years, but the authorities are organizing evacuation exercises to prepare the population just in case. The Italian volcano looks like an innocent kitten compared to the real giants like Yellowstone. For a volcano to deserve the title of a super one, it must be able to produce catastrophic-scale eruptions and eject huge amounts of magma, ash, and volcanic gases. The Yellowstone giant meets these criteria. Even though it moves from time to time, the Yellowstone supervolcano hasn't erupted for 640,000 years. But when it does wake up, it might erupt with incredible power, about the same amount as 10 huge nuclear power stations can produce. Under the ground, beneath Yellowstone, there's a super-hot area full of molten rock called magma. As more magma moves into a big space called a magma chamber, the ground above starts to swell or rise. When the magma cools down, the ground falls. Between 2004 and 2009, the ground at Yellowstone rose by almost 10 inches, but then it started to slowly go back down in 2010. Scientists aren't sure if it's going to erupt anytime soon. There's also another big volcano called Long Valley in California that has been active since 1980, and it can be a really big threat. Scientists studying this supervolcano found out that before its biggest eruption, 760,000 years ago, the buildup may have taken less than a year. Now, that's bad news, because a supervolcano eruption can have a huge effect on the world, like the eruption of the Toba volcano in Sumatra around 74,000 years ago. It became the biggest volcanic eruption the Earth had seen in 28 million years. It covered parts of Indonesia, India, and the Indian Ocean with a thick layer of volcanic debris, almost like a 6-inch blanket. The amount of rock it spewed out was like stacking nearly 3 million Empire State Buildings. The giant crater it left behind can still be seen from space. All the ash and gases shot up into the air and blocked some of the sunlight. It caused a volcanic winter that lasted about 6 to 10 years. Some scientists think this eruption might have even affected early humans. Around the time Toba erupted, the human population took a sharp dip, and there were far fewer people. Some say this is why all modern humans come from a small group of survivors. According to the Toba catastrophe theory, most early humans in Europe and Asia didn't survive the cold and harsh climate after the eruption, but a lucky group lived through all that in Africa. Not all scientists agree with this idea, and some archaeological and climate records show a different story. Another volcano that changed the world in a big way was Mount Tambora in 1815. The next year went down in history as the year without a summer. It was cold and rainy, and there was snow and frost even in the middle of summer, especially in Europe and North America. This happened because the volcano sent out a lot of sulfur dioxide into the sky, which spread all over the world and made the planet colder. When Tambora erupted, it caused huge tsunamis that smashed homes and took the lives of around 10,000 people. Afterward, about 80,000 more people passed away because of the consequences the eruption had caused in the world. The cold weather ruined crops, so food became really expensive. And because horses were the main way people traveled, the cost of oats that they ate went way up too. Some people even think this led to the invention of the bicycle in 1817, as a new way to get around. The eruption made the Earth colder for about 3 years. Now, even though the Tambora eruption was so powerful, Krakatoa, another volcano in Indonesia, stole the show when it erupted in 1883. It was just easier to spread information about it through telegrams and photos. Its final blast was the loudest recorded sound in history, and people could hear it on 10% of the entire Earth's surface. The eruption started a tsunami, with waves about half as tall as the Statue of Liberty. Now, if we only had 12 months to prepare for a supervolcano eruption, it would be really hard to store enough food and get ready. But don't panic just yet. Supervolcano eruptions are very rare, and the last one happened 26,500 years ago in New Zealand. Scientists think that a super eruption happens once every 100,000 years on average. But the sad part here is that the Earth doesn't follow a perfect timeline. There could be clusters of super eruptions with shorter gaps between them and then longer quiet periods. Since there have already been 2 super eruptions in the last 100,000 years, there's always a chance one could happen again sooner than we expect. Plus, although there are places like Yellowstone and Long Valley where we expect volcanoes to erupt, there are less obvious possible hotspots. In Chile, there's a volcano called Laguna del Maule that has erupted in the past and left behind a huge crater. Over the last 20 years, the ground there has been swelling really fast, rising up to almost 1 foot a year. Some people are worried that this could be a sign of a big eruption coming. But scientists say there's not enough magma yet to cause a super eruption. In Bolivia, the Jutarancu volcano is also acting up. It's part of a group of volcanoes that have caused super eruptions in the past. Since the 1960s, the ground around Jutarancu has been lifting, but the last eruption was 250,000 years ago. Even though the magma might be rising, it's not enough to worry about just yet. The chances of a super eruption happening during our lifetime are 1 in 1,400, which is pretty low, so you don't need to worry too much. But just like someone wins the lottery every week with very small chances, a super eruption could happen sometime in the future, and when it does, we'll need to be prepared.
You're dozing off in your window seat on a plane. It's getting dark since it's almost 11 p.m. Suddenly, something wakes you up. You glance out of the window and see a really strange phenomenon, something that creeps you out. There are bright red, huge flashes illuminating the sky at a distance. They resemble some nightmarish jellyfish. Those are sprites, also called red sprites due to their color. They're also known as cloud-to-space lightning. These varied visual shapes flickering in the night sky are large-scale electric discharges, which is a clever word for a lightning strike. They occur high above thunderstorm clouds at altitudes of 30 to 56 miles. That's why you can see them so well from your plane window. The coolest thing about sprites is that they're positively charged lightning. This is a very rare type that makes up a mere 5% of all lightning strikes. People first spotted this phenomenon in 1886, and it was first photographed in 1989. In 2018, the legendary Niagara Falls, located at the border between New York State and Ontario, Canada, managed to surprise everyone. Tourists who came to admire the roaring waters found the falls frozen. Well, the waterfalls weren't frozen per se. This is impossible for a mass of flowing water that huge, but microscopic water droplets, as well as the mist, formed a crust of ice over the rushing water. It created an illusion that Niagara Falls was frozen all over. In reality, the water kept flowing beneath the ice. Imagine ponds filled with ice-cold water and covered with ice. Easy, huh? And now picture dozens of alligator snouts that are poking out of the ponds, still and frozen in ice. That's what you'd seen if you had visited the swamps of North Carolina at the beginning of 2018. Despite this terrifying picture, the animals were very much alive. That was a very special crocodile way to survive abnormally cold weather. Since their nostrils were above water, the animals could breathe. Meanwhile, their bodies were in a hibernation-like state. It allowed the animals to conserve energy and stay warm. In the winter of 2018, the inhabitants of the Sahara Desert, one of the driest and hottest places on the planet, woke up to discover a thick layer of snow covering the sand. In some places, its depth reached a staggering 15 inches. Meteorologists had an explanation for this exciting phenomenon. They said that cold pools of air combined with the precipitation of the most recent storm resulted in snowfall instead of rain. It happened in June 2009. People in some areas in Japan left their homes after a heavy downpour, only to find fish, frogs, and tadpoles everywhere. Fields, roads, lawns, and house roofs were littered with these creatures. One man even found 13 carp on and around his truck. No one knows for sure where this bizarre rain came from, but the most popular theory is that a powerful waterspout picked up the animals. Then it carried them through the upper atmosphere and dropped them on the unsuspecting people below. In Australia, it sometimes rains spiders. That's because these creatures can balloon. It's a highly unusual way of traveling. A spider climbs to the very top of a tall tree or shrub, and then it spins several strands of silk, which then help the spider to be carried away by the wind. It's not easy to spot ballooning spiders, but sometimes when the weather is especially damp and unpleasant, mass ballooning occurs. Millions of spiders set off on a journey to find another place with better conditions. It may look as if it's snowing outside, but no, those are spiders drifting down to the ground. The world's longest lightning storms happen in Venezuela and can last for 9 hours per day. The heart of the storm is over Lake Maracaibo, and the clouds tower way higher than your regular thunderstorm clouds. This natural phenomenon, also known as Catatumbo lightning, occurs during 140 to 160 nights a year and can produce up to 28 lightning strikes per minute. You've probably heard how they say that lightning doesn't strike twice in the same place. Well, Catatumbo lightning seems not to know about this rule. At least, it doesn't prevent storm clouds from gathering in the very same place year after year. Volcanic tornadoes are possibly one of the most terrifying natural phenomena. When a volcano erupts, it spews red-hot rock and ash high into the atmosphere. And solid lava pieces and hot gases travel down the volcano's slope. When this flow is moving down, some of the trapped gases begin to rise and spin at the same time. They get squeezed by the surrounding air, which makes them spin faster and faster. That's how a volcanic tornado gets born. Luckily, this phenomenon has a very short lifespan. Even though the island of Newfoundland in Canada can't be called the warmest place on Earth, it's still not that cold. But imagine having to shovel snow in front of your house just several days before your summer vacation. Well, that's exactly what happened on the island in June 2018. A cold storm that came from the coast of Newfoundland covered several regions of the islands with a 2-inch layer of snow. On top of that, the temperature broke all the records as well. During a Newfoundland summer, it's about 66 degrees on average, and 90 degrees on a very hot day. But that infamous June impressed people with only 37 degrees Fahrenheit in the morning. Brrr! Morning glory clouds are extremely rare. They look like massive tubes stretching across the sky. They can snake for more than 600 miles, sitting relatively low. Most researchers agree that these clouds appear when an updraft squeezes through the cloud. This creates the signature rolling appearance. The cool air at the back of the cloud makes it sink downward. The best but not the only place to see the morning glory is Australia's Gulf of Carpentaria. If you decide to travel there to see these clouds, choose a period from late September to early November. On March 19, 2018, the inhabitants of Alabama saw huge chunks of ice falling from the sky. It was the infamous hailstorm of Alabama which caused millions of dollars worth of damage. After the hailstorm, the place looked ruined. Broken shop windows, smashed car windshields, broken billboards, and holes in the roofs. But what made researchers really excited was a hailstone found near the town of Cullman, Alabama. This softball-sized monster was more than 5 inches across, setting a new state record. In 2012, the sky over Dorset, England, turned first ominously dark, then yellow. After that, blue gelatinous balls started to fall to the ground. A local man was walking to his garage when he spotted something unusually bright among whitish hailstones. When researchers examined this jelly rain, they found out that the balls were made of the substance used in diapers or potting soil. It's used to absorb liquid. It's still unclear whether the balls fell from the sky or maybe the melting ice made a few already existing crystals expand in the blink of an eye. In March 2018, people in northern Nevada could see the rarest and most bizarre cloud ever, a horseshoe cloud. It sure looks bizarre and kinda scary. But meteorologists know that this interestingly shaped vortex happens when a flat cloud travels over a column of warm, rising air. This air creates the shape and adds some spin to the cloud's movements. Such clouds are very fleeting and usually last for only several minutes. Cylindrical snow donuts occur when a wind gust decides to play snowballs. It starts to roll some snow across a snowy area. If it was a real snowball, it would eventually become too heavy for the wind to move. But the center of a snow donut is hollowed out. This happens because its inner layer is too thin and gets blown away when the donut is formed. This makes it lighter than a regular snowball. That's why it also rolls further. Unfortunately, you can't just go and find snow donuts. They're rare because they appear in very precise conditions.
It was September 2nd, 1859. People all over Europe and North America woke up at night, confused and still tired. They were sure it was already morning. It was so bright outside. But when they looked out of their windows, they discovered it wasn't sunlight. The skies were lit by countless intense auroras, red, green, and purple. They were so brilliant, one could read a book as easily as in the afternoon. Auroras appeared even in the regions where they had never been witnessed before, like Cuba, the Bahamas, Jamaica, and Hawaii. Cool visual effects weren't the only thing that both mesmerized and horrified people. The most high-tech stuff at that time, telegraph wires, shorted out throughout Europe and the US. Sparks were flying from equipment, and many human operators got electric shocks. Papers and telegraph offices burst into flames. All the machines were immediately disconnected from their batteries, and still, they mysteriously kept sending broken messages. Fires, ignited by short circuits, spread over large areas. Colorful lights kept dancing overhead. All this caused panic and total confusion. Earth's inhabitants had never seen or experienced anything like that before. At that time, astronomers watched a massive eruption on the sun's surface. Within a couple of minutes, a billion-ton cloud of gas was hurled away from the star. It rushed straight toward our planet at a speed of millions of miles per hour. On Monday the 12th, the huge mass of solar plasma reached Earth's magnetic field. This storm was so fierce, it lit spectacular auroras and created underground electric currents beneath North America. These currents must have found some weaknesses in the power grid of Quebec, Canada. In less than 3 minutes, the entire city lost power. millions of people found themselves in pitch-black streets, dark buildings, and stuck elevators. They woke up in freezing cold homes, unable to cook breakfast. The following 12-hour blackout closed businesses, airports, and schools. The Montreal Metro was also shut. In the US, hundreds of power grids started to have problems minutes after the storm hit Earth's surface. Luckily, none of these issues led to a blackout. The storm was severe enough to disrupt satellite communication systems and radio signals. Some space satellites tumbled out of control for a few hours. Lots of them had mysterious problems that went away as soon as the storm began to subside. No newspaper mentioned it, but in 2012, Earth had a close shave after narrowly missing an extreme solar storm, the most intense in the past 150 years. On July 23rd, astronomers at Space Weather Prediction Center in Colorado spotted 2 clouds of energetic particles. They erupted from the sun's surface and barreled into space. Just 19 hours later, these clouds zoomed past the spot our planet had just left. If the solar eruption had happened several days earlier, Earth would have ended up in the line of fire. So, what if a solar storm as powerful as the iconic Carrington event happened nowadays? How much more harm would it cause? Would our life get back on track after such a disaster? Before you learn the answers to these questions, let's figure out what a solar storm is. The sun is a gigantic, constantly changing ball of molten gases. Every once in a while, it spews out bursts of energy, solar flares. They often go hand in hand with something called coronal mass ejections. Those are giant bubbles of ionized gas that can speed up to more than 600 miles per second. The most powerful volcanic eruptions pale in comparison with solar flares that release 10 million times more energy. Within a few minutes, one solar flare can give out billions of tons of charged particles. Solar flares are also insanely hot, with the temperatures reaching several million degrees Fahrenheit. Astronomers believe that such bursts of solar radiation happen when the sun's magnetic field gets twisted in some regions. At one moment, all the pent-up energy is released. The star sends out light and particles, mostly electrons and protons. Most solar flares last for minutes, but some continue for hours. Scientists classify solar flares depending on how brightly they shine in X-rays. You aren't likely to notice the tiniest flares if you don't have special equipment. Medium solar flares lead to fleeting radio blackouts at the poles, but nothing too serious. It's X-class flares people should worry about. They cause the strongest and longest-lasting solar storms. When people think about danger coming from space, most of them imagine an approaching asteroid, like the one that wiped out the dinosaurs. But apparently, we should be much more worried about our good old sun. A super strong solar storm heading toward Earth won't happen at once. First, there will be high-energy sunlight, mostly ultraviolet rays and X-rays. They will ionize our planet's upper atmosphere and mess up radio communication. After that, a radiation storm will hit Earth. And finally, several days later, a colossal cloud of charged solar particles will reach our atmosphere. The particles will interact with the planet's magnetic field and wreak havoc all over the world. If an intense solar storm happened these days, it would start by disrupting GPS and knocking out satellites. If any astronauts were spacewalking at that moment, they would have a mere minutes after the first flash of light to find shelter. Their spacecraft would likely be properly shielded and safe enough. The main challenge would be to get inside in time. After that, the storm will proceed to interfere with satellite communications. That's why tons of your daily activities, from calling your friends to paying with your credit card, would be at risk. But one of the worst consequences would be connected with power grids. Power surges caused by the particles coming from the sun would damage giant transformers. Those take ages to replace, especially if hundreds or even thousands get wrecked. In some places, a failure of one power grid would make others collapse as well, creating a domino-like reaction. Picture living without electricity for a day, a month, A year. No light, no computers, no phones. Water supply systems out of order. No food in supermarkets. Plus, without electricity, it would be next to impossible to reboot the already failed power grids. A powerful solar storm would cost people $1 trillion to $2 trillion, and that's just during the first year after it happens. It would take the world another 4 to 10 years to recover. The damage to all kinds of satellites alone would reach $70 billion. Under majestic auroras, people would have to get used to a new, dramatically different lifestyle. No doubt, we'd have some kind of warning. Modern equipment all over the world and in space doesn't stop watching the sun even for a second. Once a bad solar storm happens, people would have some time to prepare, between several hours and a couple of days. And if transformers are taken offline in time, the consequences won't be so dramatic. Now, the following news might sound scary. There are also super flares. In comparison to them, our sun's bursts of radiation are small potatoes. Super flares mostly occur in young and active stars. In 2016, astronomers saw such a phenomenon. A star 1,500 light-years away from Earth produced a flare that was 10 billion times more powerful than any of those that burst from our sun. It doesn't mean we're safe here on Earth. Even our middle-aged sun knows how to produce super flares, but while young stars can have them once a week or even more often, for the sun, it's once in a few thousand years. And still, if people don't figure out how to protect the planet, just one super flare can shred our ozone layer and wipe out life on Earth.